We're going to focus on domain and range. Domain and range are very important for what we're about to do. Domain and range tell us values on a graph and where they exist. Okay? So the domain of something will represent all of the x values on a graph. Okay, so domain deals with all the x values on a graph, while range deals with all the y values. Okay. What we're going to do is work on going from these forms into domain and range. That'll be easiest when doing this to actually look at a mapping diagram. We're going to do it from a table of values also, but I'm going to look at a mapping diagram. When we write domain and range, we don't repeat values. And in a mapping diagram, if you notice, we don't repeat any of the values. We only write them out once. So since these were the x values, the domain of this function, let's see if I have some room. The domain is written as d with a colon, and we're going to write all the x values. So our domain is 0, 2, and 4. Simple as that. Okay? The range is going to deal with the y values. Now, there are no repeating y values, so we're just going to write out all of the y values. The range, and we write them in order from lowest to highest. We start at -4, then -2, 0, 2, and 4. So all this other information here, these are all the different ways we can represent domain and range. So if you guys look, domain here, we have a 0. That makes sense. We have a value of 2. Now, even though we have two values of 2, we don't need to rewrite it twice. We only need to write it once in the domain. And we have two values of 4. I only need to write it once. So the domain is 0, 2, and 4. While the range, we have many values not in order, so we put them in order. -4, -2, 0, 4, and 2. Those are all of the y values, which is exactly what we found from our mapping diagram. And that's what it'll look like here. Okay. Now we're going to talk about using domain and range and looking at graphs to tell if something is a function. Okay. In order to be a function, we have to pass something called a vertical line test. So we're going to draw a vertical line down this graph through all of the x coordinates that have values. If the vertical line crosses a value only once, then it is a function. This is called a test to see if something's a function. But if it crosses it twice, like in these examples, then it is not a function. Okay? So if you draw a vertical line down a graph that has values, if the vertical lines, and you draw them through every x value, only touch some function once every time like this, then yes, it would be a function. But if we have something like this, and we draw vertical lines and it's crossing through it twice, then no, it won't be a function. Okay? That was a side note about whether something is a function or not. Now what we're going to do is we're going to create another question here. In this question, we're going to deal with domain and range, but this one is going to be a little more difficult. Okay? I'm going to put up two different types of functions. Actually, I'll do it like this. Here's one function. And what I'll do is I'll put a circle for the other function. Okay.
So if it touches more than one x value, then it's not a function.
On the x values, if it touches more than one y value, it's not a function. So let's look at this function here. We're going to talk about domain and range. This one is not as simple as before. Before we had just specific coordinates to write domain and range. It was really easy. We just wrote the numbers out, right? In this one, it's continuous. In other words, every number between there exists. So to write every number would be impossible. There are so many different numbers between 0 and 1. We could point 0.1, 0.2, 0.111, 0.121. We can make up tons of numbers to write. It's pointless to write it that way. So instead what we do, if it's a continuous function like this, so for the green one, the domain, we started off with x is the element of all real numbers. In other words, x is every real number. Okay? So we write it this way. And this lets us know that x, no matter how far we go left and right, because there are arrows, it's going to exist. There's no restrictions on it. It's going to go forever. So instead of writing all those numbers, we just write this as a short form. It's very important we know how to write the short form. That makes things simpler for us. And because there's no restrictions, this will go left and right forever. We end it there. X is every number possible. The range, though, is going to be a little different. The range is also continuous, so we're going to start it off with y, because range deals with the y, ER. Such that, though, and what I'm doing is a restriction. If you notice, it only exists below 0. It doesn't exist in the positive range. It will go down forever, but it'll never come back up here. So we have to remember our greater than and less than signs. And what we're going to write is y is less than and equal to 0. That is our restriction. It only exists below 0 on the y-axis. Okay? So let's do another question like that. We're going to focus on this circle. One way we can focus on this circle here is to kind of draw lines to the side. I'm going to zoom in a little. I'm going to move it so it's... Oh, no, it's pretty much where I want it to be. Okay? So let's talk about domain and range this way. Put this guy in blue. So domain is only x values. So I'm going to see how far left and right this one exists. All right? So if we look at its domain, this function exists between these two lines. And we can draw lines if that will help us out. All right? It exists between these two lines, those lines on the x values being 2 and 8. It's continuous between them. So what that means is our domain, we're going to start it because it's continuous with x, ER, but it has restrictions. What are those restrictions? We have 2 and 8, right? So we have our lowest value, 2. We start with the lowest value, and we know that x is greater than and equal to 2. And it's also less than and equal to the highest value of 8. Okay? So in other words, what this is saying is x is between the numbers 2 and 8. We also have to do the y values of the range. Okay? Same idea. I'm going to draw some lines to help me out here. We know our y values are going to exist between these 2 points. So our range for this question, it's continuous between those points. It's not just a bunch of dots. It's actually a line. All right? Some type of curved line. So our range is still YER. It still exists. And it's continuous, but the lowest point is what value? 3. So we know y is greater than and equal to 3. And what's the highest value? Less than and equal to 9. And that's how we'd write the domain and range for something like this. Now, briefly, let's quickly talk about this also. Vertical line test. Is this guy a function if I draw vertical lines?
No.
Yes. Why yes? No matter where I draw it, it's going to only touch it once. So yes, this is a function. If I draw vertical lines through this, why not? It's definitely hitting it twice. So no, this is not a function. Okay? So we've gone over domain and range and whether something is a function or not. It's probably best if you're given something like a map in the style of a mapping diagram or coordinates to put it on a graph and check using vertical line test if something is a function.